Chapter 13, Number 12. A position versus time plot for an object undergoing simple harmonic motion is given in the figure. Rank the 6 points indicated in the figure according to increasing speed, and then increasing velocity, and finally increasing acceleration. Indicate ties when necessary. So we want to go back to this and we want to say, well, what's going on at each place? At point A, it's at the equilibrium point, and then it's as far as possible from the equilibrium point, and then back to the equilibrium point, and then as far as possible the other way, and then back, and so on. So our picture would look something like this. Now we know on any position time graph, the slope of the graph is the velocity, so we can actually tackle part B probably fastest. And so we look over here at the slope at each of these points. We see we have a relatively high and positive slope here. The slope has gotten a little bit lower here. It's 0. Now it's negative, but the same as magnitude as part A, and now it's a little bit slower. And then over here it's even again. So a couple of things we see. Certainly C equals F, because they're both 0. And then D and E are both negative, so they would be the least. We want to go of increasing, so we want to go from least to greatest. So the least, in other words, the most negative is D, and then the next most negative is E, and then C and F are both 0, and then B is a small positive number, and A is a giant positive number. And this is part B, which is kind of weird. And part A is going to say, well, the speed is just the magnitude of the velocity. So we just want to say, we want to get rid of the negatives or positives. So we're still going to end up with C equal to F because the absolute value of 0 is 0. But we can also see that D and A are the same, which means they're going to pop up over here. And then it looks like B and E are the same, and they're going to be down here. Oops, sorry. B and E are the same, but of course they're greater than 0, so we'll have B equal to E in here, and then that'll be less than D equals A. So now we have C and F have a 0, so they're obviously the slowest speed. B and E have intermediate speeds, and then D and A have the same maximum speed. So that's part A. And then part C is based on the fact that A is minus omega squared x. So A is just the opposite of whatever x is doing. So here we can see that A and D are going to be the same because they're both at x equals 0, so have a force of 0. And that when you are at point C, we're as far as possible from the origin in a positive sense, so we're as big as possible in a negative sense for the A. A is minus that, minus some large number. And then we see that B would be intermediate in there because it's closer to the origin but still positive. And then likewise, part location F will be the greatest possible acceleration, and then location E is intermediate. So we end up with something like this. And that's part C.